BitVM 1, you had like, let's say 3, 10, 20 operators. One of them had to be honest. And then with BitVM 2, the goal was not only to, get rid of these 70 transactions, but make challenging permissionless so that anyone in the network could make a challenge, what Ethereum actually has.
Alexei, welcome to the Bitcoin Rails pod. How are you?
Great. Thanks for having me.
Yeah, I've been meaning to have you on for a while, and I'm glad that we were able to make it work before we both left Denver. How's your Denver been?
Great. I mean, it's been busy as usual. It's quite interesting that, an ETH conference for us turns out to be one of the most active and productive ones. Obviously, we love Bitcoin Nashville and Vegas, but Denver is one of my favorites, to be fair.
Well, Denver, they care about utility, right? I mean, like they care about DeFi, they care about programmability, all of these sort of Bitcoin L2, Bitcoin Renaissance, items on the agenda. I think Bitcoin conference is a little bit more split in their attention there, right? So
yeah, it's been evolving. Like, previously it was still very focused on Lightning and, Bitcoin, the asset. It's been getting better, I feel like, in terms of innovation. But I mean, I think Denver's still like so focused on like, how do we build these things?
It's technical conference, right? I think that that's something that people don't necessarily appreciate about Denver. It's like, it is fundamentally a technical conference, and like in a way that the Bitcoin conference is really not. Although we love Bitcoin conference, obviously.
Absolutely.
So you are the founder of Build on Bob, which, I mean, I remember when I was like first starting to hear about the sort of new deluge of Bitcoin L2s, in sort of a post-ordinals world in particular. I remember hearing about Botanix, Build on Bob, and Babylon as like three. It was like a triumvirate. You were like the first, one of the very, very first L2s, as they were, that were like raising lots of money and kind of like getting a lot of mind share. I'm curious to hear a little bit of, the story of how Bob came to be. I know it was very sort of interrelated with the development of BitVM. You're also co-author of BitVM 2. But I wouldn't mind, if you wouldn't mind sharing a little bit of sort of your pre-Bitcoin background, because you weren't in Bitcoin before Bob. You were in a different ecosystem.
Well, actually, I mean, we were always a Bitcoin-focused company. I've been working in Bitcoin research for 10 years now.
Oh, I didn't realize that.
And so I was never, I guess, something you'd call a like laser eye maxi. I always was excited about what else we can do. So what really, drove us to, build the company and like try out different bridge designs was the fact that, Bitcoin started this whole movement, but you can't do anything with it except for payments without trusting an exchange or a centralized provider. And that just feels so weird, so wrong. It's like a controversy. You have Ethereum, Solana, all these cool new things happening there, with all the pros and cons naturally. And then Bitcoiners are forced to, I felt like we were, as a community, forcing people into either Lightning, which can do payments and, works.
Nothing else.
But it doesn't really solve a lot of the problems, if you want to take out a loan, if you want to, actually put your Bitcoin to work, earn some yield. Everybody has their own preferences and demands. Whereas, all these other ecosystems were like desperately looking for Bitcoin. They wanted that liquidity. They wanted to bring those users in. And yeah, I mean, I've been working on Bitcoin bridges for almost 7 years now. So
I have to ask, you must have been like a child savant working on this. Were you like a teenager working on this, Alexei?
I accept the compliment. No, I started when I was writing my bachelor's thesis. So I was.
Okay.
I think I look a bit younger still. That's good.
I was going to say, I was like, this kid must have been like a teenage prodigy, like working on Bitcoin bridges.
It's not as.
You're a little older than you look, perhaps.
I think so, yeah.
Okay, fair enough. We won't dox your age.
Please don't.
Okay, so fair. So you've been working in sort of the Bitcoin, specifically bridging. I mean, 7 years ago, how much were people talking about this? I mean, I had Dan Held on, who I know is one of your investors. I had Dan Held on yesterday, and he was saying that, he even really only started seriously talking about this and, kind of getting the rumblings of this conversation in like 2022. I mean, was there conversation about programmability on Bitcoin prior to that in your experience?
Oh, yeah, there was.
Like, how was what was that like? I mean, 7 years ago, we're talking about 2018?
It was very academic at that time. But interestingly enough, if you actually, look at the research, you had WBTC come out in 2018, right? But then the research of how to build bridges, the original Bitcoin sidechains paper is what, 2014?
Right. And was that a Blockstream?
That is Adam Back, Blockstream, and the whole Blockstream crew that kind of described, okay, how could we build Bitcoin sidechains? And I kind of, got into Bitcoin at the same time when that came out. I saw Rootstock kind of emerge. I saw Stacks transition from Blockstack, where it was trying to, become another name coin, to Stacks, like, trying to be a sidechain. Um, and for me, it was always quite exciting to see like what else can we do with Bitcoin. I personally got involved in this interoperability space through merge mining, actually. So
Really?
I had the chance to write like the first academic research paper, like looking into merge mining, describing how it works, and also highlighting, it's not always great. You can get a lot of centralization if like only one mining pool operates it and the others don't.
This is the problem with merge mining is that like if you don't have a lot of hash actually doing it, then it's basically a centralized chain.
That is the risk, right? Like Bitcoin's hash rate is quite distributed. I mean, right now you sometimes have like some entities arguably controlling up to 40%. It's hard to kind of always determine the percentages, who owns the entities in the background. But with sidechains like Namecoin and others where, they're merge mined, they inherit Bitcoin security, which is a great trait, right? But it's opt-in. Like, you don't have to merge mine. And then only if you have, let's say you have like 10 mining pools, if only like the three biggest ones do it, well, suddenly you're centralized.
Right.
And there've been enough cases, like Luke Dash Jr. taking out Coiled Coin using his like mining pool. So, and that's kind of what.
Right. Not everyone is a good actor.
Well, I mean, arguably that thing was a scam coin, but still, like, should you do it? Should you not? Is a different question. Uh,
Was merge mining like the early side chains, like just going back to sort of the early sidechain history, Atom Back vibes, were the early side chains all merge mining essentially? I mean, was that the primary architecture for consensus?
well, I mean, the definition of a sidechain is a bit kind of,
Loose.
it's loose, right? It's like it was used as like, the overarching umbrella term to describe anything that is kind of built around Bitcoin. Merge mining actually comes from Satoshi himself.
But were most of the side chains at that point, meaning like layers that were like bridged to Bitcoin in some way, were most of them using merge mining for their own consensus? Was that like popular back then? No,
It wasn't.
it wasn't
So
a thing.
rootstock, I mean, so merge mining started as a way to prevent hash rate fragmentation. You had a lot of, we always have these cycles when people launch new
That makes
things.
sense.
And back then you started seeing other chains. You had like Litecoin, Namecoin emerged, then Dogecoin emerged and later, but then you had all these other kind of altcoins that were really chains of themselves, and a lot of them were just forks of the Bitcoin code base. And they would introduce like different proof of work mechanisms. And the idea that, I mean, as far as I recall, and like digging through like the history of Bitcoin forums, the idea of merge mining, and it was actually coming from Satoshi himself, was okay, well, you have all these other networks. It's good that you innovate, it's good that you experiment, but let's not fragment the hash rates. Let's
Makes
keep
perfect
the
sense.
hash rate on Bitcoin, like let's keep it like concentrated on BTC, and then let you opt in to merge money with other chains.
Right. You don't want people to leave, like you don't want miners to leave Bitcoin or securing Bitcoin to go secure Doge. Right.
Exactly, right. You want them to do both, ideally. I mean, Litecoin and Dogecoin are both merge mined too, right? But they are separate because they introduced a completely separate like mechanism where you couldn't use the same ASIC miners as you use on Bitcoin. But that essentially is kind of where it started. And for me, merge mining was like the first way that you had two chains actually connect. Because Namecoin verifies Bitcoin's proof of work. What you do in merge mining is, the miner builds a Namecoin block, but doesn't really mine on it. You just build a block.
Namecoin? I've never heard of this.
Namecoin was the first altcoin. It came out in 2011, and that's what actually got me
Like
into.
earlier than Ethereum.
Yeah.
Okay,
Namecoin was like
Namecoin was the
altcoin.
first altcoin definitively ever. This
Yeah,
is a non-controversial opinion.
no, that is
Okay.
like it's 2011, and you had Litecoin follow afterwards, but Namecoin was the first
And it was
altcoin.
a fork of, I've never heard of it. This is crazy.
Namecoin is basically a fork of Bitcoin Core where you introduce additional functionalities so that you can inscribe domain names. So basically, Namecoin was trying to create an alternative domain name system, so decentralize the internet. So you could register a website without asking for permission. And I was, I was a computer scientist by trade, like, doing a bachelor's thesis and I was really into IT security. And, naturally that felt great. Like, oh, we can decentralize the internet. Censorship resistance is great. And Zuko had this really nice paper where he had like this triangle with like, the three things that you can get. I don't actually remember. One of them was censorship resistance and the other things were like decentralization. And I don't know what the other one
But
was.
it really is sort of like a precursor to this broader theme, which I think is so important, which is like, like decentralizing data storage,
Yeah.
right? I mean, that's essentially, I mean, that's an ongoing theme, right? I mean, domains may be a thing of the past, but that was probably influential in just thinking about Bitcoin as a
Could be, yeah.
decentralized database. Yeah.
And the idea was, well, it inherits like ideally all of Bitcoin's hash rate. It didn't always get that. It ended up being centralized quite a few times. Um,
And it wasn't merge mine, so it was fragmenting at that time, which was like an
well, no,
issue.
it was merge mine
Oh, it
actually
was
then.
merge mine
So
right
then
from the beginning.
that I don't know.
Okay.
No, I think no, not true. No, it wasn't merge mine initially, and then they upgraded to merge mining. And you
Okay.
could actually, I remember now, like we were looking at the Namecoin like hash rate, which was like really, really low, and then merge mining started and then just jumped, and it became like super secure because now if
Everyone
you
could
want
do it both.
exactly, so if you wanted to attack it as some state level actor, you'd have to buy a lot of hash rate and be able to attack Bitcoin as well. So that was kind of how I got in. Unfortunately, when Namecoin didn't work, it got completely squatted, because you don't have a way to verify like soul-bound identities. Everybody, miners were just like squatting the domain names
Right.
because they didn't know what to do with the Namecoin tokens they were getting. And that's how I kind of got into merge mining. Merge mining was kind of one of the reasons why it didn't work as much, in my opinion. And then it took, because like that's how we kind of ended up going into, well, we can use merge mining to secure other chains. What else can we do? Can we, I always was excited about what else we can do with Bitcoin, not just the monetary policy thing and like Bitcoin as money. Um,
Was it just like a general, I wonder, or did you have specific use cases at that point that you were like interested in progressing?
I mean, DeFi only became relevant grew much later, but I always felt like, if you want to, it was actually about trading initially. Like, okay, I want to trade, buy another asset. I don't want to go to a centralized exchange. And, the centralized exchanges back then were really like, I mean, I remember using Poloniex and like Cryptopia, man, that was a bit wild. Like, I mean, I remember like
This was before my time.
buying some of my first like, and I didn't have a lot of money. For me, like the investment of time was like already a lot. Like everybody, my parents were thinking like, what are you doing? This is like, everybody was telling me, oh, Bitcoin's dead. It had just come down, right? It was like worth $200, come down from I think 1,000. Everybody was like, oh, it's dead. This is such a waste of time. I remember like, spending like hours and hours trying to buy like, I remember thing was Cardano,
Oh man.
on like Cryptopia. It was terrible. So
Just like bad UX, basically, like these early centralized exchange. I mean, I just think of Mt. Gox when I think of early centralized
I
exchanges.
wasn't that early, so luckily I didn't lose money on my Gox. I think I did lose a bit on Cryptopia, luckily not much. I always, back then, I'd buy something.
Did
Again,
they also lose money? Did like Cryptopia have
Cryptopia
like
got
the
hacked, yeah.
okay,
I still get the emails about, but I never, I would buy, again, I didn't have a lot of money, so I'd buy a few dollars worth of a coin and then
yeah,
I actually take it to the wallet.
smart.
But yeah, and then I by coincidence got the chance to do a PhD actually, at Imperial in London.
In this space, what was
Yeah.
your PhD in?
So it was initially I was looking, so blockchain.com was funding a research position at Imperial College, and the first thing that they wanted us to look into was Lightning. So the blockchain.com was developing their own Lightning implementation called Thunder, and I was supposed to contribute research to that, look into how we can improve it. I never was a big fan of Lightning. I felt it was
Never.
no,
Were you unimpressed by the permissionless exit and like the incredible, ability to like be sovereign?
no.
That didn't impress
I mean,
you.
no, it was cool. I mean, it was like the research around it was cool. But again, it used the limited tools Bitcoin had, like HTLCs, and it was so clunky. And if you look, I remember look at that paper, and I was discussing with research colleagues, how we could use these mechanisms. HTLCs were widely known for atomic swaps, so we're using the same mechanisms to create cross-chain swaps, and like looking at research in that direction. And of course, then cross-channel swaps are very similar to swapping between the different chains. But I remember looking at the paper over and over again, like within like even a few days, just to try to remember the transaction flow. It was so convoluted, complicated, and it still is. And for me, it felt like, anything that becomes so complex, and I know now we're doing BitVM, so bear with me there.
Yeah, I was gonna say.
But it just it felt very complex, and I didn't think that we'd see a lot of adoption on the retail user end.
Right. Well,
Plus,
certainly not in like a self-custodial way.
no.
Like, yeah, right, right.
And I was also more or less more excited, as mentioned, about things that we could do with Bitcoin other than payments. And like for me, payments, I can send you money on Bitcoin. Yes, it's 10 minutes, but I can send you $1 million. I can send you $5. It's the same fee. That kind of works. We had seen remittance use cases kind of emerge at that time. and I didn't know anyone who was actually buying Bitcoin a lot at that time, less to speak of like using it to buy coffee. So it kind of felt like maybe we're a bit early, but then
We're
also
still early for that.
true.
Yeah.
And then the block size wars happened. And again, I wasn't as involved in that. I was more like on the sidelines observing. I feel like, when you start your PhD, you get something called the imposter syndrome. Everybody feels so smart and you're so far behind. And you have these ideas and you realize, oh, this was published like 3 years ago. And you get closer as you do more research. And at some point you start like finding new stuff. And I felt I felt quite intimidated by all of these big names and like people who have been in Bitcoin for so long debating online. And I don't know. I didn't feel like I was in a position to really start, getting involved in voicing my opinion.
Were people in academia, I mean, you now reference this twice, both getting your bachelor's and also on the PhD track. Were people in academia really talking about Bitcoin that much? I mean, I
Oh,
feel
yeah,
really,
absolutely.
really.
I mean, if you look
And
at
for cryptography, what was your PhD in?
so my PhD was in distributed systems.
Ah,
So, I mean, cryptography. Look, I mean, I guess yes, we're using cryptographic primitives, and we have a good understanding. And when ZK proved like zero knowledge cryptography started getting traction, obviously we spent a lot of time trying to learn and understand how these things work. But I'm like Eli Ben Sasson as a cryptographer,
right.
right? Because I'm like Jens Groth, they're cryptographers because they really work on the lower levels and like
It's a
actually
very
mathematical
specific part
primitives.
of what we're doing.
Exactly. Look, I mean, I understand how it works. Am I the person to come up with a new like ZK primitive? Probably not. Like that's not my specialty. We use cryptographic primitives as tools to then build bridges, other protocols,
Distributed
payments.
systems,
Exactly.
broadly. Do you think distributed systems like a regular, was that unique at your university or is that a regular
Distributed systems is
subject?
like a very broad, like, it has nothing to do with crypto per se. It's a very broad kind of domain in computer science. My PG actually focused on Bitcoin. Like I was one of myself and Dominic, my co-founder, we were the first two full-time PhD students at Imperial that did Bitcoin and
But you
Ethereum research.
chose that. The other folks in your program were doing various different things in distributed systems. Distributed systems was like the overarching academic
I mean,
subject.
well, the way it kind of works is I was doing so I did an internship with my professor there, and we were actually attacking mining pools, like something completely different. He comes from a performance modeling background, but was really into Bitcoin and crypto, and it was like setting up this research lab. And they were like super. It was super early, and I applied to do like an internship there for 6 months, just to get out of the country, get some abroad experience. And we ended up attacking like Ethereum mining pools in the reward distributions. And then there was a PhD opening, and someone actually had dropped out. So the position was actually already like filled, and then that person dropped out last minute, and I happened to be there. So he asked me, do you want to do a PhD? And I kind of never thought about it before. Um, and it seemed actually quite interesting because it was again funded by one of the most well-known companies in the space at that time. So it had this kind of nice research and industry kind of mix. So I did the interviews and, they liked me. I think I was quite deep into the space back then. There were not that many people, who knew a lot of like these like cross-chain concepts, merge mining, lightning.
Well, this is my point, right? Is sort of like it couldn't have been that well discussed in academic circles. You must be like with the right professor at the right school, right? I mean, are there specific programs? If somebody was interested, if somebody was like listening was interested in like going an academic route to get deeper into the space, what would you recommend?
I mean, now it's easy, right? You have a lot of blockchain labs. You have blockchain courses at universities. So that has over the last like 6, 7, 8 years, it really developed into like a proper subject. Back then, I mean, like in my course, in my university, I was like the only one that was really looking into it in my kind of in like my group of friends and like the broader course. There was nothing out there. My like advisor for my bachelor's and master's thesis, he was like a PG student and a professor, and he was into that topic.
Right.
So
Follow
like
the
that was just
professor.
it was basically lucky. Like I got lucky by talking to the right person who was into that topic and willing to like have some students like dig deeper into that field. And then my professor at Imperial was just for him it was more of a hobby, I think, and he was in the process of setting up a lab and getting funding for it. So yeah, it was actually like for academia it wasn't as early, to be fair, because there was a lot of fundamental research that had happened. You have a lot of the big names like Agelos Kayas, who then work with Cardano and IOHK. You have Emin Gün Sirer, who went off to do then Avalanche. And I feel like a lot of these big names actually went off then to build other chains, and that happened after these block size wars when Bitcoin, in my opinion, entered a bit of a dark age where anything to do with innovation, altcoins, adding functionality to Bitcoin was shunned.
It was like, this is the final update, basically. Like SegWit happened, and they were like, we don't want to touch Bitcoin anymore. And then the like wave of L1s came around to sort of address the lack of innovation.
I mean, Ethereum, like it all emerged at the same time. I mean, again, that's my perception. As mentioned, I was not as directly involved. The only like the direct involvement or direct impact it had on me was that blockchain.com basically, said, okay, you know what? Let's look at how to bring Bitcoin. I mean, I was always into interoperability. We were doing some research on the side, but it wasn't my main research topic initially. And then we kind of agreed on, Bitcoin's not going to change. Let's not try to fork anything into it. Let's figure out how we can bridge Bitcoin to other systems and like build sidechains without modifying Bitcoin. And that was in 2017. And so we started working on trust minimized bridging, designed a trust minimized bridge that used collateral and like economic game theory for security. So think MakerDAO. So the idea is anyone can be an operator, and if you're an operator, you lock up collateral in like stable coins and other assets on the target chain. If I deposit my Bitcoin with you, I get a wrapped asset. We use like cross-chain proofs to verify that the payment on Bitcoin happens, so it's like trustless, the process. But if you steal my Bitcoin, I'm going to take your collateral. So I'll get reimbursed in these other assets. So it's super secure. It is to this date. It's actually live. We built it later on in the company. We actually, when we did the spin out, we started building this design.
Let's break this down because I want to understand this better. I feel like this is important, especially because like, right now, like the narrative that I've always heard is like there is no real like trustless or even super trust minimized bridging to Bitcoin that exists. It's all like federated multi-sigs until BitVM came along.
Well, that's not quite true.
The story that I think many people have heard. So let's debunk it. Let's get into it. So explain this to me. So you're saying in 2017, there was this like alternate architecture for bridging that actually, in your opinion, could claim some level of trustlessness?
Trustless is so
trust minimized.
Yeah. So the problem that kind of we encountered throughout, so my PhD the goal was create trustless bridges.
That was the goal of your PhD in
PhD.
2017. Yeah. You set that intention.
Yeah.
Okay.
And then like halfway into it, we kind of realized it doesn't work. We actually proved that it's impossible. So the result of my PhD and the title
was it doesn't work.
Trustless Bridging, Impossibility and Practical Solutions.
Wow.
So we gave like a fundamental we in computer science you can prove in a model under some assumptions that you cannot do it, and you kind of prove that look, if we could solve some of the fundamental computer science problems like the halting problem, you can't predict given any program whether it's going to stop or not. Like you have to know exactly what's in it. So that's like one of the fundamental problems, and you prove that if we could solve bridging between two different blockchains without trusting anyone, you'd kind of solve that problem too.
So how did you come to because what is this previous architecture that you mentioned? So it basically proved to not actually be workable.
So we played around with so many concepts, and we realized, okay, the best thing we can do is if you have two chains that have smart contracts, and like Ethereum can verify Bitcoin, right? That was already possible since 2016. There was this thing called Bitcoin Relay that, would read the Bitcoin block headers and you could verify transactions. So same as
because it has a VM, basically.
Exactly. And Bitcoin is easy to verify.
Yeah.
But Bitcoin can't verify Ethereum. But if you had two Ethereums, you could actually, have Ethereum 1 verify Ethereum 2 and Ethereum 2 verify Ethereum 1. So you wouldn't need you to kind of have the smart contracts enforce the bridging. But then what we realize is, okay, you still need someone in the middle to submit the proofs, right? If nobody is online to submit something to the system.
But this is, are you including Bitcoin in this right now? Or are you like bridging?
This is like abstract.
This is
if we had ideal case, two chains that are like super powerful, they can verify each other. That's like the best possible design.
Right.
But even that has some trust assumptions. You need someone to, take the data from chain 1 and submit it to chain 2.
You need a middleman, basically.
Exactly. And we realized, look, you always need a middleman. There is no way around it. But the best thing you can do...
Which is what a bridge is, essentially.
I mean, bridging is all about custodying the assets while they're being used on another network. And we realize, okay, so we always need a middleman. And the best thing we can do is, reduce trust in that middleman. And then what BitVM does, right, it takes a middleman and it says, oh, the entirety of Bitcoin is now verifying that process. And like we still need one operator somewhere in BitVM. So we again have this trust assumption of somewhere someone is online, but you need to have someone online to trigger a fraud proof.
Okay, so let's pause on BitVM for a second.
Yeah.
So basically you did all this research trying to figure out if there was a way to do trustless bridging on
Yeah.
Bitcoin, and your final answer after doing like a full PhD on the subject was that it's impossible.
Not just for Bitcoin, any two chains, you always have to trust a middleman. But then the second part of the title was "and practical solutions."
Okay.
So
What were the practical solutions pre-BitVM? Like,
yeah.
just for context, what were the practical solutions that you were recommending?
So if we had two smart contract based chains, verify each other. And that's
Okay.
actually, we saw Polkadot, Cosmos, all these other ecosystems emerge that tried to exactly do this. And then for Bitcoin, it was, okay, we can't hack like the assumption back then was we can't hack this. We can't hack like a light client for another chain into Bitcoin. It doesn't work. So we need to emulate that functionality. How do we emulate that? You had multisigs, but we don't like multisigs, right? It's like centralized. You have 3 out of 5 signers. And a big multisigs didn't really
Still
scale.
centralized. Yeah.
So what we said, okay, we took a different approach. Let's look at the economics. Like we're dealing with financial assets. Why would you steal? Well, because you want to make profit. Well, what if I take that away from you as an operator? What if I prevent you from ever making profit if you steal the Bitcoin? And
So you're trying to play like an incentives game, essentially.
Exactly.
Right.
And what we did, we said, look.
But could you set it up so that you still run into this problem, I assume, where like if the honeypot is big enough,
Yeah.
Maybe stealing is worth losing the money on the other side.
So it becomes financial, and that at that time also DeFi was emerging. So, and like Dominic, my co-founder, he came from Ethereum land. So he was actually into DeFi stablecoin designs, and we collaborated on this design where we said, look, we have these operators. We don't want to trust them. We don't want to use super complex cryptographic primitives for that because it should be easy to run. So what the operator does is when they register, they lock up collateral on the target chain, on Ethereum actually. They'll lock up ETH and stablecoins and other assets.
Mm-hmm.
And if I want to bridge Bitcoin in, I'll go to Ethereum and say, hey, I want to bridge in one BTC, and that will lock up the collateral in the smart contract. So now I have like one Bitcoin worth of collateral plus, let's say, a 50% like buffer to account for like price fluctuations.
But so you need quite a bit of liquidity provision.
Exactly.
This is the problem.
And that's the problem. That's why it works. It just doesn't scale. And well, we learned this the hard way later on. But it is to this day the most trustless bridge design out there. And we released a paper for that. We got published. We actually went to Scaling Bitcoin back then and presented this. The feedback we got was like, well, we don't know if we really need altcoins, but it's a really interesting concept. Let's have them present this.
So basically the idea is like, as long as you can force bridge operators essentially to put up the collateral that sort of meets the liquidity demands of whatever the honeypot is that they could steal, then you're in good shape. But doesn't scale, obviously, because liquidity provision requirements are way too high.
Exactly. The operators need to make money. And look, if you want to bridge like $1 million worth of Bitcoin, you need $1.5 million locked up as collateral.
Yeah, it's crazy. Yeah.
But academic mind.
But it's a good idea, right? Theoretically, you're on to something.
Yeah, exactly. And we actually built it in production.
You did.
So we released the paper, and then we were suddenly approached by Cosmos, Polkadot, Avalanche, Solana, Rootstock as well, and hey, do you guys want to build this? Because we need trust minimized bridging, and that's the only solution.
When was this? This was like
2020.
2020, okay.
That was 2020 already.
Okay.
So we were kind of at the end of our halfway through our PhDs and already kind of towards in your PhD you have to get one top tier paper, like a star level, where it's really tough to get in, and then you're kind of safe, and then you do a few more and you're kind of good to go. But you have this requirement that was kind of, for me, that was my was accepted in a tier 1 security conference at that time. And then, we were approached by these again, startups as well.
But you chose Polkadot basically to do most of your work at the time. Why?
So we looked at the infrastructure. I had known Polkadot's design for quite a while because, I was looking into interoperability, and the idea that we had was, look, we have all these different chains, all these different architectures. They all want Bitcoin. For us as a business as well, it's quite risky to accept funding from all of them as a service provider. And then if one of them stops paying, then I have to fire 5 people off the team. I have to also hire different engineering teams because all of these stacks look different. So we looked at the different stacks, and Polkadot's substrate was built in Rust, which is a really good programming language, works well with Bitcoin primitives, and it was quite robust already at the time, much further developed than Solana or Cosmos. And the other problem was Ethereum was too expensive. for
Mm.
this. Already back then, it would have been way too expensive to actually keep posting the Bitcoin data to Ethereum.
The Ethereum scaling problem was already
Was
a
already
thing.
there. And actually, before we went to spin it off, I, by coincidence, got the chance to collaborate with Rami, who was a PhD colleague at the time, on arguably the first Ethereum rollup paper.
Mm.
So the first rollup paper that Ethereum like kind of claims to have existed is Plasma. And then at the same time, actually, Rami in his master's thesis already had written that design up and published it. And I help basically, how we can make it more understandable and how this design can be better structured. So I already had kind of, taken a deep dive into the ETH rollups as well. Academically speaking, that paper, it's called Nocust, is the first paper that actually explains how to build a rollup. They were called commit chains back then.
And when you say rollup, are you specifically referring to ZK rollups?
Well, kind of. So not quite. So
Or just like the
different.
concept of like data availability on like the base chain? Like what was your definition at that point of a
It wasn't
rollup?
called rollup. It was called commit chain. And the idea was you had a separate off-chain ledger. This one was used specifically for trading. And actually Rami found a way to prove that all of the trades were valid using a ZK proof, actually. So he was already way into this back then.
So you were using Z. So it did include ZK.
But I have to also say, for me, it was a bit of a black box. I started learning about it. So at that point, it was like, oh my God, this math looks so complicated.
Like, what is this new cryptography that's happening?
Exactly. But
he was using Ethereum knowledge proofs.
So super early as well. And actually that's when Groth 16 started to become quite popular again, because it came out in 2016. That's what we use as the main proving system for most of the ZK proofs right now.
Okay.
So yeah, again, it was a lot of new things happening at the same time. And we then said, okay, let's, Bitcoin needs to be bridged. So we went out and, started working with Polkadot. And the motivation there was, okay, Polkadot is meant to connect to multiple networks. That was always the premise. We actually were talking to them to help them build the Ethereum bridge.
They were an interoperability. That was their mission, was interoperability.
Exactly.
Okay.
Unfortunately, it turned out that, bridging Polkadot to other chains is very difficult, specifically the Ethereum bridge to Polkadot. It took years to develop just because of how complex Ethereum is, and to verify Ethereum efficiently on another chain, that's really hard. It still doesn't properly work.
So they struggled with their core mission, essentially.
Exactly. And similar to Cosmos and the later Avalanche, what happened then is that you had Polkadot, and it could connect chains that were of the same design within Polkadot, and same Cosmos would connect Cosmos chains.
But not outside, which is the key important point.
Exactly. And that's where we got stuck, because we built the bridge from Bitcoin into Polkadot, and our goal was, okay, well, you had Solana wanted one, Avalanche wanted one, and the goal was, okay, from this, the project was called interlay. So it was supposed to be the layer between Bitcoin and all these other networks, because that's the hard problem. The assumption was, and we were obviously wrong, that if you have smart contracts, you can easily verify each other. What we didn't think about is that on the engineering level, these smart contract chains are so complex that verifying the other chain efficiently is actually very difficult.
Super just data intensive, or more complex in other ways?
Just because these proof of stake consensus mechanisms are new, complex, and not as robust as proof of work. Proof of work is super easy to verify on Bitcoin because it's also so simple, whereas on Ethereum, the Ethereum to this date does not have a secure light client. It just doesn't have one yet. Other chains tried to do that, but again, even Solana, all of these chains prioritize functionality over simplicity in verifying it. And there's a trade-off you have to make, right? If it's a very complex system, it becomes harder to verify it without downloading all the data. And if I would to say, okay, I'll store all the data from one chain into the other chain, well, then it's what am I doing? I'm just copying Solana into Ethereum. That doesn't work, right? Then Solana and Ethereum become the same thing.
Right.
So that was kind of our excursion into Polkadot. We learned a lot of hard lessons there. About, tech is not all that matters. If you build a super secure system, but it's hard to use, it doesn't scale, you don't talk to the operators up front, you don't talk to the users, not going to work.
Right. If you accomplish a goal, but it's a Rube Goldberg machine, it has other problems.
And then, of course, there, we also had the experience with, ecosystem support, how to do BD, communicating properly what you're building is important, making sure you treat the ecosystem partners as clients. We had a lot of interesting experiences there, a lot of learnings. And eventually we exited that ecosystem and said, look, that's not working. It's we were getting dragged into a lot of these Polkadot specific topics, and we were actually a Bitcoin company. Our mandate was at that time also with the capital raises, like, okay, make Bitcoin more useful.
You wanted to bridge into Bitcoin even while you were in this Polkadot
Well,
universe.
Polkadot was a means to an end. We were never like a Polkadot max or whatever team. Our goal was, okay, make Bitcoin more useful, and Polkadot seemed, when we started, a good tool, and it turned out that it wasn't in
It's
that
kind of like
case.
you almost wanted to create like an L2 of Polkadot, right? I
Oh
mean,
yeah,
sort of like a Bitcoin L2 in a way. Like it was sort of
exactly.
an
Yeah,
alternative to a sidechain, essentially.
yeah.
So at what point did you kind of say, give up, raise your hands and say, I'm not doing this anymore?
Well, we never stopped like working on Bitcoin. It was just we realized that's not the right approach.
Polkadot was not the right
No.
approach. Yeah.
And neither was Cosmos. And we took a step back and tried to like we looked at Stacks, Rootstock, Liquid.
When was this?
That was 2022.
Okay. Right before like the ordinals,
Yeah.
BitVM wave. So you had like a few months to process before.
We started working on Bob for 6 to 8 months actually before BitVM was announced.
Okay. And
Um,
what was the original intention of Bob pre-BitVM? Like
so
what?
the goal was so we had other bridge designs in mind that were kind of scaled better than this economic security model. We had a lot of optimizations there. We also had designs that used more like, again, economic models like synthetics with like trust minimized redemption. So we went more the DeFi route.
Okay.
I still think these designs can work quite well, actually, especially with like restaking and so on.
Okay.
It was quite interesting to see like a lot of,
Multiple designs. There's multiple designs here that we
yeah.
could get into. Okay, interesting. Pause.
Um,
Pause on that.
but
Okay.
then like when BitFame came out, it was like very clear, okay, like this is it.
Like
Like
this is our
I
life
have
now.
to admit, I would have like we had given up on hacking these things into Bitcoin without a fork. So all the credit goes to Robin. Like without him actually going and like trying to hack these things into Bitcoin script,
So
I had already resigned in terms of trying to hack it into Bitcoin. We went like the other route of like, okay, how do we build economics that scale around
you
this?
were playing the incentive. You went back to like the incentive games that we were kind of describing earlier. Like, how do you kind of make bridging a little bit like how do you like hack the game theory basically around
Well,
bridging? That was sort
both.
of
We were trying to use, so what we're looking at two things. Synthetic bridges,
what
where,
does that mean?
so basically you lock up Ether, or like you wouldn't lock up Bitcoin when you bridge it. You'd mint it using stablecoins Ethereum. You create a synthetic that's value backed by another asset, but you'd enforce redemptions like swaps against Bitcoin. So you basically create a model where it's profitable for you to actually, trade the synthetic against the layer one BTC with atomic swaps.
Okay.
And I think that actually, interestingly enough, like it came back, a lot of that came back into what we're doing above again.
Right.
Um,
But that is essentially sort of like a game theory
like more
incentive
DeFi
adjacent.
focused.
Yeah, yeah.
And then the other route we were taking was, okay, but I can build trust minimized bridges for specific applications. What doesn't work, so we came up with a lot of, we
Oh,
combined,
interesting.
like we were combining commit chains and rollup designs that we saw in Ethereum with the tools we thought we had. We didn't know about BitVM wasn't out then. So we're using like HTLCs, PTLCs, adapter signatures, and all the things that kind of were available on Bitcoin back then
Right.
to create things that work with one specific use case. So usually what you want from a bridge is you get a fungible representation of Bitcoin that you can use with whatever you like. But that comes with a lot of problems. That's challenging to build. But if I would say I only use it with this one specific lending application, and I can maybe plug that into a stablecoin.
There's
And
like ways to
only
hack
do that.
trustlessness in those situations, basically.
Exactly. I mean, if I prevent you from doing with that wrap Bitcoin whatever you like, it's basically the smart contract always controls it. So like you deposit Bitcoin into this product that does something with it, but it gives like a Bitcoin backed stablecoin, but you can't do anything else. Like you cannot like move the Bitcoin around. You can do a very specific like the smart contract controls what you can do. You lose fungibility.
And there's examples of this. I mean, people are building kind of like I'm thinking like Atomic, right? Like
Yeah,
the small
DLCs
Bitcoin
were kind of
swaps. Yeah, like
going in that direction.
there's
Yeah.
sort of like weird ways that you can create trustless systems around specific use cases,
Yeah.
but it's not the universal solution that maybe BitVM
Exactly. So that was
provided.
the trade-off. We call them application specific bridges, and we had a few interesting designs where you could actually, generate returns on your Bitcoin. You do like um, arbitrage between different like lending and stablecoin protocols. And then at the same time, we actually, took a very pragmatic route. We said we're building a hybrid. because we believe that DeFi exists on Ethereum, and we want to enable these users to, use Bitcoin.
Hybrid consensus mechanism. Which consensus mechanisms are you
So it
hybridizing?
was initially merge mining. So an ETH rollup that would also have merge mining on top.
Okay.
So ETH rollup with fraud proofs, or at that time it was already pretty clear that ZK proofs would work better than fraud proofs, but then you'd have merge mining on top.
What was the intention behind putting merge mining on top? Just like additional layers of security for the second layer?
So you basically have you'd have Bitcoin security on top of it. And for us, and then
Bitcoin security. That's a little loose.
Exactly.
I mean,
so you'd have some level.
You'd have hash on top. Hash.
Exactly.
Proof of work security for whoever opts in.
Yeah. So there's different flavors of Bitcoin security, right? You have full Bitcoin security. If you could do a full ZK rollup on Bitcoin, every full node would actually execute the proof and check this L2 is correct. With fraud proofs, you do something similar, but you only check if something goes wrong. So
otherwise known as an optimistic rollup.
Exactly. And that's where you kind of, in some form, at some point, get all the Bitcoin nodes to check what's going on. But then merge mining and also Bitcoin staking with Babylon is a level below that a bit, where you have a subset of nodes. Anyone can opt in to participate. And in this case, in the merge mining case, it's the mining operators. In the staking case, it's anyone who stakes Bitcoin. So it's a subset of Bitcoin nodes that have to do something like merge, have hash rate, or lock up their Bitcoin to be allowed to secure the chain. And that's it's not as strong as every full node, but it's very, very good if you get a lot of people to do that.
So let me back up. So basically you have the architecture here that you're developing is essentially this sort of trust minimized bridge plus merge mining that's securing the actual second layer on top. How important is merge mining securing the second layer on top if you have the trust minimized bridge? Is that sort of replacing DA being published on layer one?
So the idea was the trust minimized bridge would have what we would basically do is we'd outsource as much of the logic into the L2, into Bob at that point, because it has smart contracts, but we somehow need to enforce that the smart contracts are safe. We could plug it into Ethereum, which is arguably secure enough, but again, to be aligned with Bitcoin, to make sure that there is this Bitcoin security, especially as a Bitcoiner, if you want to bridge your Bitcoin, let's say we come up with a bridge that, works with application-specific things with the tools we had, or these economic primitives. Okay, you bridge into something that has no Bitcoin security though. So that's why you need the merge mining on top to have some level of Bitcoin security.
How would you compare this though? So I'm thinking of a lot of the BitVM ZKP implementations that are built right now or being built right now. I'm thinking
we scrapped all that, right? So that was the initial design, and then Robin released BitVM in December.
I see. So BitVM essentially replaces the need for a lot of this.
Yeah.
Okay, makes sense.
And then I actually got asked to interview Robin and Super Testnet, which were the two guys that actually, were working on BitVM at that time.
At a conference or something?
On the Ordinals show.
No way.
And I was like, okay, this just came out. And they were like, Alexei, you were on the Ordinals show before. You've been doing bridge stuff before. Can you go and ask a few smart questions? I have no idea how this works. I'm supposed to take some time off. All right. And I spent 8 hours digging through the Telegram chats, because there was this initial write-up.
This was April. When did BitVM come out?
December 23.
Wow. Interesting.
And
so Trevor was is Trevor an investor? Is Bitcoin Frontier Fund invested
they also then
Bob?
invested into Bob afterwards, later on. And he basically, so Trevor is the reason why Bob, how I got into BitVM, because
that's wild.
Hey, I needed to can you please do that? And I spent 8 hours learning up, and there was the write-up was one thing, but it had so many open questions, and it was only a protocol between two people, not for bridging or anything. And then there was this long thread of 1,000+ messages where there were some way deeper discussions going on than actually in the paper. Yeah, Shinobi and a lot of the OGs actually debating, what can we do with
the
it?
maxis were obsessed in the early days, yeah.
And so I spent hours, and I was digging through the thread, through the Telegram chat, and actually okay, this is actually
you
really
became
cool.
obsessed.
And I had a lot of open questions, so I got I had my kind of asked Robin and Super Test a bunch of questions on the show, and then connected with Robin afterwards and looked also at his profile, and I heard his name before because in 2021 he released a paper called Stake Chains, which is what Bitcoin staking is today. So Robin not only came up with BitVM, he also came up with Bitcoin staking.
Like the Babylon style staking with like the reveal
Early
key?
version of that. Babylon is obviously they collaborate with Robin to advance it much more, and it's much more powerful than the initial design. But yeah, and then
Oh my
of
gosh,
course,
Robin, what a heartthrob.
and
Okay.
then and also have to actually give Jeremy Rubin a lot of credit because a lot of these things Jeremy already had described in some forum posts early days. So like it's quite interesting to kind of trace it back.
Interesting.
It's actually great to see Jeremy back in the arena, I guess.
Oh yeah, Jeremy's getting back into action.
Yeah,
He'll be on the pod at some point.
so that's pretty cool. And then my like kind of thinking was, oh, can we build a bridge with this? So I basically
Wait, let's pause there for a second. That actually was one of the official questions on my list. So BitVM, I mean,
yeah
when Robin introduces
yeah.
BitVM, he says this is a bridging solution. But that's a new idea. When he first created BitVM, it wasn't as such. How would you have defined his intention with BitVM 1? Like, what was BitVM 1?
No, Robin, I think from if I recall, I mean, initially the goal was to hack a ZKP verifier.
Okay, so it was always a bridging solution. It was always designed for basically being able to verify information off chain and put it on chain. Is that a fair way to describe it?
I mean, it's hard for me to, kind of see into Robin's mind. What the background I got from Robin was that actually before the paper came out, for 8 months, they had been experimenting with how to hack a zero knowledge verifier into Bitcoin script. Because what people don't know is Bitcoin script, with Bitcoin script, you can write universal computation like any program. The problem is they get really, really big because like something that's like 1 line or like 5 lines of code in Solidity is like 1,000 lines of code in Bitcoin. Like even multiplication, you have to like write yourself.
Yeah, it's crazy.
So, and they were like trying to find ways like to hack this
and to compact it as much as possible.
Like split it across multiple transactions. And what they came up with was this fraud-proof based design where you play this interactive challenge game where the initial version of BitVM was 2 people. I say I'm going to run the ZK verifier program off chain, and I commit to it though, so you know what it should look like.
Right.
I give you the result, and if you verify it on your computer and it's different, what you'll do is you'll challenge me.
Right.
And then we'll play
the expensive game.
Exactly. We'll play this game where I basically have committed to an execution trace, like the entire trace of like running the program. And now you're trying to find the spot where I modified it. So we jump back and forth, like challenge, response, and you kind of do a binary search trying to find where I made the change.
So you're solving the problem of verifying ZKs on Bitcoin being very, very difficult, very expensive, taking multiple transactions by basically, only forcing people to do it if somebody calls someone's bluff.
Exactly, yeah. So that was the original concept. And I sent Robin this write-up of like, hey, could we build a bridge like this? And Robin had also worked, I saw on his website, and it's like some like, he was zeroing is actually a way to compact like Bitcoin into a ZK proof, so you can like sync up nodes faster, so you don't have to download all the blocks, but you just verify a proof that everything until block 1 million was correct. And he was working on some cross-chain client stuff that I also had been working on, so I really got excited about like, hey, okay, he's worked on like some cross-chain bridging stuff, at least that's how I understood it. And then Robin spent like a few hours with me correcting all my wrong assumptions about BitVM. And we kind of started working. I suggested, you know what? Why don't we like try to figure out how to build a bridge with this and like do a bridge write-up? And that's how we started working. And ultimately, during that process, Robin had a lot of improvement ideas about BitVM, and that's how like BitVM 2 came into play. Again, Robin deserves all the credit for all of that, right? I mean, my role was mainly supporting and like, giving ideas and challenging a few assumptions, and then like making sure that we actually got this paper written up. So I brought in a few colleagues from my research days to then help with like the writing up the structure and making sure we actually have a proper design.
Would you say it's fair, just for folks who want like the TLDR, so like BitVM 1, the intention was essentially hack a ZKP verifier into Bitcoin. BitVM 2 is, okay, let's take that idea and optimize it for bridging as much as possible. Is that a fair way to describe it?
I would say so, right? So what's the main use case? I mean, Robin is also working on ZK coins.
Bridging, yeah.
But bridging ultimately was the main use case for BitVM 2 for that design. And the paper is called BitVM 2 and bridging to Bitcoin layers.
Initially, so, I mean, you guys wrote the paper. I think there were a couple other co-authors on the paper. Initially, were all of these companies that were interested in building roll-ups and bridges, the Alpen Labs and the Citrias of the world. I mean, at what point did they start contributing? At what point was the BitVM Alliance created?
So a lot of these teams had started working on like the early stages of BitVM, and you saw a lot of like, in my opinion, in the early days, the BitVM chat was the best Bitcoin research chat in ages. I mean,
I believe
it was
it.
brilliant.
I believe it.
So much text, so much innovation. Like you could feel this innovation heartbeat accelerate. Like
Yeah, it sounds
Alpha
exciting.
Labs come up with like Snarknado, and Citria was experimenting with their bridge designs. It wasn't quite there yet though, because it was all based on BitVM 1, which had like a lot of transactions and people, and then you kind of had this split off of a few designs that tried to optimize this like binary game.
That was the game, was optimizing the game to make it as
Yeah.
compact as possible.
And then when Robin's idea, like within this like bridging design process, Robin came up with the idea was like, okay, let's not do this interactive game. Let's take a ZK verifier and just plug it in, and you change the structure. So instead of trying to optimize for like a RISC-V architecture where you like then have to do the binary game, you basically would say, look, we take a program, we pre-process it first, and we generate a ZK proof, a snark proof over the program, compress it to a fixed size, standard way of how it looks.
Was it his idea to use snarks specifically, which is a specific type of ZKP that's like smaller and easier to deal with?
Well, the difference between snarks and starks is the verifier for a snark is constant size, but for a stark it actually isn't quite constant.
Oh, so it's less like reliable.
It's less predictable. In that case. And when we're working in a very resource constrained environment, specifically Bitcoin, that was the idea.
Was it so? He was originally working with Starks, and then he switched it to Snark. We don't know.
I think it's always Snarks, but these are details that I don't know.
I'm getting super nerdy right now.
It's all good.
Yeah. Okay, but so the move to Snarks though was like a specific type of zero knowledge proof that was like reliably sized, essentially, like predictably sized, so you could kind of have.
So I want to be careful not to put anything like any like words into someone else's mouth. Like that's my understanding.
Okay.
But I'm sure Robin will be able to really
Oh, we'll get into it with him. Yeah. But yeah, it's helpful to kind of understand sort of what this like evolution was for folks who just kind of want the basics. Basics.
I mean, it was a really exciting time, and the limitation of BitVM 1 was not this like that you had to do like 70 transactions back and forth,
right?
Over 6 months.
Jesus Christ!
Which is like, but it proved
that you could do it.
Like exactly, it was like, oh my god, it works. Like,
yeah, you could have a one of n bridge.
Exactly.
That was the innovation.
It was exactly, but the n was fixed size. So in BitVM 1, only with the operators could challenge each other. So you had to know who the.
Was there a constraint on the n?
Yeah, because the setup, you have to do a lot of pre-signed transactions. So the way we do this in BitVM is we need to make sure that like the Bitcoin that is deposited can only be spent in a certain way. Mm-hmm. So the operator can only spend it in a way that I can challenge.
Right.
Since we don't.
So all the n have to pre-sign transactions.
Exactly, for each other.
Isn't that still the case? How do you fix that?
It is still the case. It's still the case.
Yeah.
It grows exponentially. There are improvements by now that become more. You trade off complexities, but there is actually another improvement that is more like linear. That is quite new.
Okay.
But that came out much later. So back then it was exponential, and like the end was constrained. You could probably like 10, 20, 30, 50. 1,000 was like
pushing it.
I mean, just the amount of computational overhead you have to do at the start would just make it like very, very expensive. Like literally like on the servers.
Is it the type of thing where like the more you compress the data, the bigger n can get? Like
that was literally just the amount of pre-signing you had to do as a function of like the design of it.
How do you like limit the complexity such that you can increase the number of signers and therefore decentralize this bridge?
Well, I mean, BitVM 2 is certainly already easier. But so the idea here was that, okay, the reason we needed to scale the operators was because the more operators, the more people could challenge. Right? If you only had like three operators, okay, what if the three of them collude?
Right, it's centralization risk.
Exactly.
Yeah.
So in the BitVM 1, you had like, okay, let's say 3, 10, 20 operators, one of them had to be honest. And then with BitVM 2, the goal was not only to, get rid of these 70 transactions, but make challenging permissionless so that anyone in the network could make a challenge, what Ethereum actually has. So it was really getting to that point.
Anyone meaning like you don't even need to be an official operator. Is that accurate? Okay. So that's a huge, that's a major distinction.
I mean, it comes with a lot of complexity on like the
but it's a huge benefit, and it increases the trustlessness like infinitely. If you can be your own challenger.
Exactly.
Yeah. So basically trustless to yourself.
Yes. In BitVM 2, there's like a slight limitation there. In BitVM 2, you need to have one of the operators needs to be online. to process the transaction. So
Okay.
if all of them collude, the worst thing they can do is freeze your funds, but they don't gain anything from it because they can't
There's
steal.
no incentive.
Just
Yeah.
think of it like there's like 50 operators and they all are malicious. They try to steal the money and you'll challenge one after the other, kick them out. At some point, you'll have no one left. But they make no money. So like the economics are not there for you to try to attack this because you know you will be challenged.
You'd have to want to like fuck with somebody for a non-monetary reason.
Exactly. But then the system is designed that the operator also has some deposit that they lose. So like they're actually making a loss if they try that.
Oh, okay. So they're really you're disincentivized from
Yeah,
like
exactly.
DDoSing
Like you're gonna
essentially.
lose some
Yeah.
money, and like you can freeze someone's Bitcoin, but and that's why sure, like I can also when I do a BitVM2 setup, I can also try to be part of the operator set if I'm depositing a large amount of
So
money.
all of these teams are basically in like a Telegram chat, like nerding out about this. And is that how the Bitcoin Alliance eventually like came to be? Like,
So the BitVM Alliance is a bit different. So that came later.
okay,
So that came back a year after BitVM, the original paper was released, and then a lot of these teams are working on like forks or versions of BitVM 1, and then together with Robin, and we brought in a few research colleagues from mine from TU Vienna.
okay,
They were these guys had previously worked a lot on Lightning and bridges as well, and I
okay.
got a very good understanding of how these things work. And then we actually wrote up a proper spec before there was
For
a spec.
BitVM 2.
Exactly, there was a
Okay.
proper
I
spec.
remember when BitVM 2 spec came
Yeah.
out. Yeah.
And then they also wrote up a full spec for BitVM 1. So like two fully
Oh,
like academic like for BitVM 1 there's actually now a paper that is under submission to an academic conference with like full proofs that
oh,
the system is
interesting.
secure.
Okay.
And for BitVM 2 that's in the works to actually not only just show like the full spec but prove under which assumptions this is correct and like is secure and what are the bounds for like how much hash
Who
rate
audits
you
that?
have.
Like a bunch of professors? There's like a handful of like academics that just
Well,
like,
you have like proof systems that are pretty widely acknowledged that's you make certain assumptions like the attacker does not have infinite resources, you can't break Bitcoin, you don't have a quantum computer, so like
so there's systems for like basically
there's like
defending
frameworks
this
exactly, and you prove that under this framework under which we anyway operate.
and you test it.
Well, you basically write like a proof. If this all holds, I mathematically prove that this is secure under certain like
Condition.
yeah.
Interesting.
In
Okay.
practice, there's always like additional considerations. Like it can be secure in theory, but unusable in practice. So, you always like, there's a limit to how far these proofs go, but it's
Right.
very good to actually have that because you can like, the edge cases.
We won't know the practical realities of this until like there's like a test net. I mean, there's
Mainnet. Like you never know,
Yeah.
like in this space, because there's always money on the line.
Right.
You really never know.
Until mainnet.
Like there is like you can estimate what the cost will be to attack this and so on, but there's so many like dynamics change, like the fee rate could change. So you try to
Yeah.
predict things and you assume like okay, the
Right.
fee rate is not going to explode, so you can't like
But who knows?
BitVM, you assume that you'll be able to publish a transaction into Bitcoin within a certain period of time. You assume that I cannot be censored by the entirety of Bitcoin.
That's always one of my like major questions with these BitVM challenge response games is that in order, let's just say that there's a challenge and somebody needs to defend themselves. It takes at the moment, I believe, multiple transactions, regardless of the BitVM implementation, multiple transactions to actually like make these commitments and like prove
Yeah.
yourself, right? In my mind, I'm like, okay, so what happens though if the fee rate changes substantially between transactions? I mean, is that a concern?
So it's a parameter of the system. So the duration of the challenge periods determines like how likely is it that you're going to have a very high fee rate consistently for like 7 days, right? The chances of this are much lower than if you have only a few hours.
I see. So
So
you
if you
give yourself
decide
time.
like,
That's why it's a
Udi
multi.
comes along and starts inscribing some new like ordinals within like if we say the challenge period to like only like a few hours, and during that time you have somebody inscribing ordinals,
I see.
then it might be a problem. If it's like 7 days, the chance like, good luck trying to like fill up Bitcoin blocks for like 7, that's a lot.
So you have a certain number of days to get these proofs done, which is like specifically designed for like fee rate variability.
It's similar to Ethereum. Like Ethereum has had this whole debate why 7 days on the fraud proofs, and now they're actually debating we could do it reduce it to 3 days.
Interesting. And it's a debate, right? Because there's trade-offs.
Exactly.
Yeah,
And I
makes
mean,
sense.
then there's ways also to basically, I mean, maybe set it like based on the amount you're withdrawing, you maybe have to wait longer or shorter. But in BitVM, yeah, you need like multiple transactions. But then BitVM 2, like in BitVM 1, it was like 70 to 150, and then they got it down to like 30, 40, and so on. And like in BitVM 2, it's in the simplest form 3. And then
That's the best
yeah,
that can be
but
done.
then there are 3 big ones, and you can optimize to have more transactions, but then they're smaller size.
Right. It sort of also depends on the
Exactly.
transaction.
But the simplest design was, okay, I commit. Initially, we do the setup. and then there's a peg out transaction. So if you're bridging out, I have to make that payment. And if I don't do that, or I do it in the wrong way, then the process begins. And the way that BitVM works is, and that's a limitation of just how Bitcoin script is set up, as an operator, I have to prepay. So I actually take my own Bitcoin, I'll send it to you, then I'll claim it back from BitVM. And the reason we do this is that in Bitcoin,
so the operators take the risk, and retail isn't stuck like holding a 7-day bag. Yeah.
The reason is that just the way our Bitcoin script is executed, like it's a one-time thing. There is no state in it. And when we set up BitVM, we have to know who can withdraw. Because we don't have covenants, or we don't have even ZK proofs, I need to know who are the people who can withdraw from BitVM when I set up the instance. Like that's just how Bitcoin script works. Unfortunately, without forking your opcodes into Bitcoin, we can't get around it.
Yeah, it makes sense. And so this is a service they're providing for a fee.
Exactly. So the operator, I'll send you, let's say you're withdrawing one wrap Bitcoin, I'll send it to you, and then I'll go to BitVM and say, hey, I've done that.
Are the fees fixed? Okay, so then this is like my core question, right?
Yeah.
And this is why I keep bringing up the BitVM Alliance is, are all of these teams, all of these different teams who are building these rollups, these L2s, are they going to be implementing a canonical BitVM 2 bridge?
No.
Okay.
So the BitVM Alliance was started by Robin as a way to coordinate GitHub contributions to my understanding. Again,
people were just contributing
Robin,
research.
Like it's also best like to have Robin.
I'll talk to him as well,
because like ultimately he's been like the person who's like pushing that. And kudos to Robin actually for keeping this all open source and kind of making sure that all the teams have incentive to contribute back to this open source kind of code base. So, but you have this core code base, the core BitVM primitive, like how do you set it up, the covenant committee, the operators, like the actual transaction flows, and like making that you have to split the way that BitVM works is you take a program and you chunk it up into pieces. Like that's how BitVM 2 works. Since you don't have to do the binary search, but we take a snark verifier in Bitcoin that's around 1 gigabyte in size, and we chunk it up into
commands.
Yeah, sub-programs before we even do anything with BitVM itself. Before we do anything on chain, we take it and we chunk it up.
Okay.
To chunks of like 400 kilobyte to 4 megabyte.
Okay.
So you can fit it into a Bitcoin block.
Right. Okay.
And execute each one of them individually.
Okay.
And if you run them one after the other, you get the same result. A good way, and I love explaining this using multiplication as example, right? Okay. In Ethereum, if you multiply two numbers, it's like A times B is equal whatever. Mm-hmm. And in BitVM, what we do is we then split this program up and imagine like you're just adding.
Oh.
Like it's oversimplified, but that's a good way to think about it.
Okay.
And then in BitVM 2, I commit to running this program. And if you challenge me, I have to reveal the intermediary results. So let's say you're asking me to multiply 2 times 10. I say it's 19, which is obviously wrong. You know that. You can check on your local machine. Let's say you have to do a lot of computation.
I don't even need to do the calculations to know that that's wrong.
Yeah,
this is the point.
It's oversimplified in that case. If it's like a bridge execution, you have to check like, oh, okay, was the Bitcoin burned? And you didn't send it to the right person.
The key idea here, and I remember Robin actually spoke about this on stage the other day, is that it's easier to prove something's wrong than prove something's right.
Yeah.
It's less computationally intensive. On
Bitcoin specifically, yes.
Okay.
On Ethereum, we're actually seeing different dynamics. We're doing a ZK proof is easier than FRA proofs at this point, which is interesting.
Okay.
On Bitcoin, because we can't take the full verifier and put it into a transaction, because again, it's a gigabyte in size.
Yep.
Bitcoin is only like max is 4 megabytes. So what we have to do then is we have to figure out where were you wrong, at which stage of these, like which of these many programs was wrong, what's the first one that you kind of modify. If you're a smart attacker, you're not going to just steal, you're going to try to hack it in. You're going to just try to change one small part.
You can only disprove, right? You can disprove chunks essentially.
Exactly.
So the BitVM Alliance is, so this does not mean that these teams are all using a canonical version of this bridge, but
there's actually multiple teams that work on different implementations. The way I would see it is there's like a core primitive, core designs, there's core problems of how to do these things, and there's like also like work on audits and like
would you say that they're competitive in the sense of like trying to like create the best implementation in a bubble, or are they making these sort of different design decisions because their second layer has different demands?
I mean, I don't have as much insight. So the initial so the way it started was that the initial BitVM Alliance was created to really contribute to the core code base. We had focused mainly on BitVM 2 research. So we didn't actively join that initial BitVM Alliance.
I remember this.
Yeah.
You guys weren't originally going to build your own BitVM implementation.
Well, we were.
Oh, you were.
We were basically, the goal was teams that contribute to the public GitHub repo to actually do stuff. We were not yet doing that. So, I mean, yes, we designed like with Robin, we were like...
We were very supportive, yeah.
But again, it didn't feel like right pushing like, oh, we should be part of this just for politics because, well, no, fair enough. It's like, who is really contributing to this core part of like BitVM? And then we started contributing to that later. And now also like are getting involved with it. But it's also a lot of politics involved. And, not everybody was part of the alliance. And now then more teams started joining. Um,
So anyone can join? Or do you have to be invited?
well, I think you have to be invited. So,
Okay.
yeah.
Because there's a lot of new, I mean, I hear new projects like every day who are
Yeah.
like trying to do some sort of ZKB BitVM implementation more and more. Like,
I mean, it's
surprised.
open source. Like joining
Anyone can do it.
is more of like you're contributing. So like now there's
Research.
audits and like there's going to be like funding. So we're going to be contributing funding to audit the whole thing because ultimately, there's all these teams that want to make BitVM work. We all have our own versions because
Yeah.
each BitVM design implementation depends on what are you connecting it to.
And there's BitVM, each BitVM 2 implementation will be different than the others, but there's also like there's like BitVM X
Yeah.
from the rootstock guys. I mean, there's lots of variations.
BitVM X, for example, forked off a BitVM 1 design and went the route of optimizing that. BitVM 2 is a different kind of track, and that's where I think most like of the work is like concentrated.
Right, that's where like there's the most teamwork happening.
Yeah, but then again, they're contributing to each other. Like, so Sergio from Fairgate, who's working BitVM X, they post research, and like there's always debate and infighting, and like, oh, is
Everyone's watching each other.
Of course, yeah,
Yeah.
but it's great because you have competition, you have different designs, there's feedback, and ultimately it moves the entire space forward. So the way I expect it to happen is, I mean, our bet is it's going to get commoditized. That's why when we're working on this BitVM2 research paper, my goal was just get it out as quickly as possible. Instead of, Bob trying to like, oh, this is better. Like, let's start, developing this
Right.
in-house and then, because look,
You're like, let's build everything else and basically take the like best open source like software that we can and like plug it into our like amazing ecosystem. I mean, that's sort of the idea.
Well, I mean, we have a quite pragmatic approach. I mean, we already knew that there were teams like Fiamma emerging that their focus is to take that and make it available to everyone. Like they want to commoditize BitVM.
Yeah. So why like, yeah.
That's why we partner with
right.
Fiamma. They're a really good engineering team. And for us, it was like, okay, faster time to market. We get this out faster. And, we have our own custom bridge design. It
Right.
works specifically.
And you have other things to do, right? Like, you know what I'm saying?
Yeah.
Like there's like only so many resources. Like, other people are building open source stuff that you can essentially like have access to. You might as well spend your resources building out everything else that needs to get built to make these ecosystems.
I mean, if it were so easy, I mean, it isn't quite because there's a core BitVM implementation with like the proving, the splitting logic, but then what we're building for Bob is actually quite custom. Because each BitVM implementation depends on what is the consensus of your L2.
What it's bridging into. Exactly.
And Bob's design is a hybrid, which is very unique.
Right.
To everybody, like a lot of teams are trying to roll up their only to Bitcoin, post all the data. I don't think that's going to work anytime soon. It's going to be too expensive. So we take a slightly different approach. We partner with Babylon. Bob is an ETH rollup right now, right? We're a hybrid. We're going to be connected to both Bitcoin and Ethereum and later other chains. Like our goal is to be
interesting.
Like, if you compare this to what I mentioned about interlay, right? There's like similar vision, but our goal is to allow users from different ecosystems to use Bitcoin. But then what we know is that, well, all these other chains, if you like what we discussed initially, don't have secure light clients. So building BitVM to Ethereum and all these other networks, that's not going to work really well.
Interesting.
It only works well for things that have Bitcoin security. So if I only need to look at what's in Bitcoin, then BitVM can be built. And it's still difficult, but it can be done.
It sort of reminds me a little bit of what the Bitcoin OS guys are doing, right? In the sense that like there's this like modular, like you're plugging into other ecosystems.
We're quite different to that. So we're not a bridge builder in that sense. So Bob's design, we have like 3 phases. We start as an ETHL2. And now what we're rolling out on testnet is we add Bitcoin finality to this. So as an ETH rollup, you have a sequencer that produces transactions and, posts. And what we're going to be doing, we're going to be posting ZK proofs to Ethereum.
Would you say it's more accurate to say like you are your own execution environment, but you're going to be interoperable with all of these different?
Yes.
Okay.
But in a different way. So we're not trying to build BitVM bridges to all these different chains because I don't think it works.
You build the bridge to your own Bob execution environment, but that environment can interact with different ecosystems, which is distinct from a bridge, like just bridging directly into those ecosystems.
Exactly. I mean, also bridges don't make money. That's the other thing. Bridges don't make enough fees, like, to operate them. In our assumption, like...
Right, so having 1 million bridges. Oh, so that's an interesting critique. So, like, basically having 1 million bridges to different ecosystems doesn't work because it's not, the incentive isn't there.
Only if you route a lot of the assets back and forth. And look, I mean, generally what we see, like, even with WBTC, it's bridged in and it stays there. And, like, sometimes people bridge out. So what we're doing with
Interesting.
with Bob, like as a layer two, you have transaction fees. Like the more activity we build in our ecosystem, and then there's of course vaults where basically there's a percentage of the AUM that like people deploy Bitcoin into like Ethereum. We have new products allow you to deploy Bitcoin into Bob, then it goes to ETH in a certain product, tokenized. So there's like financial products on top which contribute to the revenue model of the system.
Mm.
A part of that will go to sustaining the bridge operation.
Oh,
That's
interesting.
the
So
only
you're
way
going to
this is.
subsidize the bridge operation through
Well, it's
these,
a
right?
core part of infrastructure. Like if that's the
Right.
main way how we get Bitcoin in, we have to pay for it, right?
No, 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 that makes sense. That
And
makes total sense.
that's this way also we can ensure that it scales because the more Bitcoin we get in, the more fees we
Well,
generate.
I mean, this
Yeah.
has been my whole thing. One of the things, it's like I feel like I'm one of these people who like has been sort of defending this model of like you have to be interoperable with like other ecosystems. That's like how you're
Yeah.
going to be, and not everyone's doing that. I mean, some of the best, BitVM, ZKP
Yeah.
builders out there are not doing that, and
And
that's sort of my greatest criticism, I would say, is like why are you building this like isolated execution environment?
yeah.
But this makes a lot of sense to me.
I mean, we learn it the hard way, right? And you've seen this before with other Bitcoin sidechain attempts. If you build in isolation, like, I think it
You just
doesn't
get
work.
liquidity fragmentation. Yeah.
Exactly. And for us, okay, every ETH user is a Bitcoin user almost.
Hmm.
Every Solana user is a Bitcoin user. Why should we exclude them? In fact, this is our core user base initially, right?
Yeah.
If you think about, this
Has
is
runes taught you nothing? Has
yeah.
you know what I mean? Has the meta protocol boom taught you nothing? Yeah, yeah, yeah. Interoperability is
And
a
that's your early adopter group. They already know
exactly
DeFi. They want to use Bitcoin. Let's
right,
give them better tools.
right.
And then we can go like going directly to someone who's never used DeFi and has Bitcoin Ledger and tell them, oh, you can put this into an AMM. I mean, what's an AMM, right? So
Yeah, yeah, yeah.
it's a much larger lift to actually get there, and you have to improve the UX. So at BAL, we have two tracks internally, and like two actual how we split the resources. One is engineering, where we work on BitVM, two, and we work on Bitcoin security. So specifically with Babylon and like adding the staking component on top of our ETH2. So when we generate the proofs, we submit them before we send them to Ethereum. We send them to the Babylon stakers that have Bitcoin staked.
Right.
They sign off. And then we include a proof that we look at Bitcoin, and at that latest Bitcoin block, there's a commitment to the state of Bob, and we can verify that they're stake locked by looking at the Bitcoin blockchain. We pack that into the proof, and that's what we give to Ethereum. So then Ethereum knows that, oh, the state of Bob is not only valid, but it's also has been signed off by the Bitcoin stakers, and that is the canonical Bob state.
It's a hash that's published onto these different chains.
No, so with that's just like Bitcoin and Bob, and that's just the way that Bob works with being connected. With Ethereum, it's a bit special right now.
Okay.
So with Ethereum, because that's where we also submit our ZK proofs, and we have three phases. In phase two, Bob is an ETH rollup that has ZK proofs that are published to Ethereum, and in addition, we have Bitcoin staking signing off on this being the canonical state of Bob. So they verify the proofs and they say yes. So to attack Bob, you need to, of course, attack the sequencer, prevent us from publishing the proofs on Ethereum or modify that somehow. So attack Ethereum and attack the majority of the Bitcoin stakers, which makes Bob in practice the most secure layer two, because you have to attack all these things to actually corrupt the system.
Oh my goodness.
And the reason we add Bitcoin staking is because we want to plug in the BitVM bridge. So our BitVM bridge version will verify that the Bitcoin stakers have signed off. So that's the security of the BitVM bridge. It's secured by the Bitcoin that is staked.
You know, it's interesting because you're the first person, and I think we are going to have to maybe even do like a part 2 on this episode, but it didn't occur to me that BitVM and the work that Babylon is doing are actually like really co-supportive of one another.
Yeah. I mean, Babylon's also researching and working. I mean, David joined the BitVM to research as well. Like,
oh, he did?
Yeah.
Oh, I had no idea.
So, like,
I think of them as being like totally separate things. I mean, everything you're saying makes sense, but this is like I'm having an aha moment about how they're sort of mutually co-supportive.
I mean, so the way that Bitcoin staking works right now is it's very simple, because the idea is if the Babylon Bitcoin stakers, if they sign off onto, if let's say the sequencer is attacking the system and we create a fork, and then they sign off on both forks, which is of course wrong. They should only pick one, the one that's valid. If they sign off on both, the way that it's done is that they will reveal their Bitcoin private key. It will be leaked. It actually exploits a vulnerability in Schnorr.
Oh, that's why they need BitVM. Yeah, yeah, because
they don't need BitVM for that. So that's actually cool, but they want BitVM to have more staking, more conditions for the slash.
Exactly. Well, this is what somebody, because I was having a conversation with this about somebody off the record about this, and they were essentially saying that like ultimately in order to do this reveal transaction you do need conditionality, and like how is that being created? And so am I getting this right, that sort of like this is sort of the element where BitVM becomes kind of relevant?
Well, I mean, we can do a lot more with BitVM. It's also more complex. Plus, like, one other cool thing is, you want to tokenize a Bitcoin stake, like create an liquid staking token, right? You stake the Bitcoin, you tokenize it so you can use it in DeFi. That's been a very strong case on Ethereum because, look, we lock up all this Bitcoin. There's $6 billion worth of it. It's securing the chains, but how do the chains actually generate revenue? You want to get that liquidity into the Bitcoin secure network like Bob. So you create LSTs. Right now, these LSTs are still custodial. They're there's very good models, where it's institutional custody, but ultimately you want this to be trustless. That's where BitVM comes into play. When we build a BitVM bridge to Bob, we can also add additional rules that you can also not just lock it up in BitVM, but you can stake it into Babylon and add a condition that, okay, your Bitcoin can get withdrawn in two ways. Either you're withdrawing it from the chain, or if there's a slashing event, the Bitcoin is gone because, well, you've delegated it to a staker, or you're running your own staker, and if you try to misbehave, you're going to lose it. So there's like really cool ways of like creating trust minimized liquid staking assets where you don't need custodial solutions in between. So there's a lot of synergy between these kind of concepts, and that's what we're working on with Bob, right? We want Bitcoin staking security. We built the BitVM bridge, and that's what's rolling out like over the next weeks and months. We have the test nets, right? We work with like Fiamma on the testnet specifically that is very tailored for that model for BitVM. And then ultimately, we'll have this design where, you have Bob as security from the Bitcoin stakers. We have a trust minimized Bitcoin bridge that is powered, like basically trusting that the Bitcoin stakers, the majority of the stake there is honest. So it's not full Bitcoin stake, right? It's not yet a roll up on Bitcoin. But then what we can do is, because now other chains can easily verify Bitcoin. So now with this finality with Bob inheriting Bitcoin finality, and this is like determining which is the canonical Bob state, any chain that can verify Bitcoin can create a trust minimized bridge to Bob.
Oh,
So
interesting.
Solana, by just verifying that, oh yeah, Bob in this Bitcoin block has been finalized and we have all the staking signatures on top, we're good. We can now deposit and bridge assets to and from Bob secured by Bitcoin. I don't need a third-party bridge provider. And that's where the hybrid design comes into play. We not only want to, have people bridge their assets into Bob, or use Bitcoin on Bob. No, I want them to be able to bridge their SOL, trade against Bitcoin, or for users who have BTC to be able to deploy their Bitcoin into Solana. There's like dozens of opportunities there to use your Bitcoin, but that you still will trust Solana if you bridge your Bitcoin to Solana.
Right.
But that BitVM BT secured Bitcoin that goes into Bob and then goes to Solana, that's built to Solana connection has the same security model. It's secured by the Bitcoin stakers.
So Bob becomes the connective tissue, basically,
Yeah.
between these different
I
environments.
mean, our goal is not necessarily to like export Bitcoin everywhere. Our goal is, every chain wants Bitcoin. We're building the tools. That's the tech side. And then the product side, we released a product called Bob Stake where you can deploy a Bitcoin from BTCL1 into any DeFi strategy on any of these connected chains with one transaction. So you don't have to, wrap and go click, click, click. It's one transaction, and it's super easy to manage, and it makes it much more accessible. And then we work with this so-called, we call them distribution channels. So wallets, custodians, staking operators, because for them, you have this one kind of API basically, where you integrate and you get access to all of these different Bitcoin DeFi opportunities. You don't have to integrate them individually. So it makes it much easier for them to just plug into Bob and allow their users to access all of these cool things. And that's already on mainnet.
It's an ambitious goal. It's funny, Dan Held, I mentioned he was on the podcast yesterday, and he said, we invest in founders that are relentless. And he specifically mentioned you as one of those relentless. He said, you and Matt from Arch Network. He said, relentless. I said, that sounds about right. But yeah, I think that we're probably going to have to do I want to do a whole part 2 deep dive about the relationship between Babylon and BitVM and what you guys are building, because I haven't done my deep dive on Babylon. I would love to get David on the pod. I have to.
You definitely should.
I need to get David. I think in Vegas, I'm going to try to get David on the pod. Maybe we'll do a part 2 in
Sounds
Vegas.
Good.
Yeah, but this was super interesting, and I have a new understanding, I think, of what you're building, which is awesome, and I'm just very excited about everything that's happening with BitVM. So thank you so much for coming on the show.
Thanks for having me.
Yeah.
Maybe one last thing I just want to mention. I feel like, we have a lot of the debates around, again, semantics within the Bitcoin and BitVM community right now. And what kind of is a bit frustrating is that if you're taking a pragmatic approach with the proper go-to-market strategy, people assume, oh, you don't care about security, which is not true.
So true.
We're working on BitVM. We're working also to ultimately be a full Bitcoin rollup.
Right.
It just doesn't scale. And why? I mean, I can go to our users and say, oh, you're going to pay to 100 to 1,000 times X the fees, but
Yeah.
you're going to get better Bitcoin security. I mean, they're just going to leave.
Yeah, exactly. Yeah,
So
exactly.
I feel like
I call it like, like trust minimization, like dick measuring, like that's
we don't want to repeat a Lightning, right? If Lightning taught us anything, is that just building only for ethos doesn't work. It needs to be a product.
Well, I don't even feel
Yeah.
like it's really for ethos. I feel like people are just competing with each other. I feel
Well,
like
that is also
it's like
true.
ego, It's
I mean,
I'm not even sure it's
entire
really
industry is
ethos.
about, I have faster blocks, I have faster transactions, it's
Yeah.
better. But what about the products? Like
Yeah.
the builders need to be able to ship products.
That's Giannis's like big like drum that he's pounding is like, why aren't people talking more about actual products? Everyone's just sort of circle jerking
Yeah.
about this like base layer tech that users don't give a shit about.
Exactly, yeah.
So I'm with you. We'll talk about that more on
Cool.
episode
Sounds good.
2 also. Cool.
Thanks for having me.
Thank you. Thank you. Awesome.